Okay, a 4 kilogram object is moving across a frictionless surface, that is key, with a constant velocity of 2 meters per second. Which one of the following horizontal forces is necessary to maintain the state of motion? Newton said an object in motion stays in motion. You do not need a force to keep something moving. The correct answer is A, and many of you got that. Very good. How come then I can't just push a book and it slides forever? Because of friction.
It's frictionless object.
Exactly. So frictionless constant velocity are your key terms there. What is the value of FF? Basically the same concept here. We've got a 20 kilogram box sliding towards the right across the floor with an acceleration of 1 meter per second squared to the left. My net force horizontally, there is only one. My net force is the sum of all horizontal forces. In this case, it is only friction. And my net force is equal to mass times acceleration, or 20 because it's 1 to the left, minus 1. 20 times minus 1, the friction force is minus 20 because it's to the left. If you had 20, you would have got a half.
No, I got a 0. That's what I got.
Correct answer is minus 20. If the forces acting upon an object are balanced, then the object must not be accelerating. Net force, if the forces on it are balanced, that means the net force is 0, which means that the acceleration is also 0. It could be moving, or it could be at rest. Okay? So A and B do not work. It must be C.
Wait, why does B work?
Must be moving with a constant velocity because it could be at rest.
What if the velocity is 0?
That's at rest, right?
So then it could be moving with a constant velocity.
Well, okay, lawyer.
Okay, so B is also...
If you wrote that down and said, if I assume that moving at 0 is...
Give me a mark.
If you wrote that down,
I did.
We're gonna write it down right now.
a body of mass of 15 kilograms rests on a frictionless surface and has 30 newtons applied to it. What acceleration is produced? This is the easiest one of the day, right? You know that, right? I hope so.
Oh.
There's only one horizontal force. The net force is 30. It is the applied force. How come? There's no friction. Excuse me.
How is there no friction? Is it in space?
Frictionless.
Is it taking place in space?
Yes. 30 divided by 15 is 2. How many people got that? Lots. Good.
I think that's what I want. See what it's two. So we're the only ones talking about. Me and Charlie are the only ones that got that one.
Oh, yeah.
I can check later. A 20 kilogram object will encounter a 50 Newton frictional force when pushed across a horizontal surface. With what force must you push the object in order to maintain constant velocity? Now there is friction.
That's good, right? We got this one. Right?
Okay? So if there's friction of minus 50, F net is equal to FA plus FF. The friction force is minus 50. Because it's constant velocity, that means that the acceleration is 0, which means the net force must be 0, which means that your applied force must be plus 50. It's a lot of math for plus 50.
I got the opposite answer again. I got negative 50 to this one.
It's got to be to the right, plus 50.
Must be stupid. Yeah.
An automobile has a mass of 1,600 kilograms. What force required to give the acceleration of 1.2 if there are frictional forces totaling 200? I'm going to guess there was a few people who got this one here wrong. Yeah, a few. Not too bad, though. Actually, that's pretty good. Here's how you do it. F net is equal to MA. We've got 1,600. The acceleration is 1.2. Somebody help me out?
You told me I got it right.
1920, right? I did not tell you that. I just told you to punch it in.
That's the number we got.
That's the net force. Do you remember me doing one like this in the example? And I said, make sure you write the formula, because you will not make the mistake if you do it right. I'm guessing that everyone that got it wrong just took 1920 and did what? Subtracted 200. This is the net force. Is that what you did, Nate? Yep, I saw it. But I also knew that if you made this mistake, you might more likely, hopefully, remember the next time, when it really counts. The net force is 1920. You are solving for the applied force. My friction force is minus 200, and I know, Nate, you did this right. And then you took that minus 200, you went over there, and you left it as minus 200, didn't you?
Wow, we're close.
Just do the math properly, man. 1920 plus 200. 2120. Nod, give me the bobblehead. Yes, got it? Heather, yeah?
Helen and I gave the problem.
Do you think that's going to show up on the test?
Yeah.
You can almost guarantee it, can't you?
All right then. Why is this negative 200?
Well, let's see what the answer for number
Positive
7.
200.
Yeah.
What do you mean? It goes to the other side, man.
Because you have to add it.
How do you get negative 200 to the other side?
Well, it's still on the right side, is it not?
Well, I flipped it around.
Okay.
Come on, man.
Just looking for the X.
What will be its velocity at the end of 8 seconds? A equals delta V over delta T. The acceleration is 1.2. The time is 8. 1.2 times 8 is going to be?
Oh, I got that wrong.
Is it not
It's 9.6.
10?
No, it's 9.6.
Oh, yeah, right. Okay, 9.6.
I got that wrong.
Your answer is off.
Mine might be.
Yeah, Mr. Bennett.
Oh, 16, yeah. Okay. I apologize.
Yeah.
I made new questions here, and I think it,
So my
yeah.
9.6 is
9.6 is right. Give yourself a mark. I'll fix that.
Oh,
How far will the body travel in 8 seconds? Before you can do that, you have to find the average. So if the final is 9.6, you've got 0 plus 9.6 divided by 2.
This is right out the equation first.
4.8.
Well, I
Mr.
guess
Bennett has
I'll-
just been told.
4.8. Uh, 32 and 8.
38.4.
What was it?
38.
38.4? I'm sure this one's likely wrong, right? Yeah.
60.
Silly.
My sailing shoes.
38.4?
Got better than me.
So yeah, you guys did okay, I think.
No, I didn't.
Don't expect too much on this.
Yeah, he got the whole time. Don't expect too much.
Okay, number 9. What is the acceleration to one decimal place of the object if the applied force is 50 newtons at 25 degrees above horizontal? Friction force is 5. Let me get rid of this mass equals 10 stuff here. I apologize. I got to do some fixing. Okay, so your first step when you see a force at an angle like this, what should you do? Find the FH, the horizontal component. FA cos theta. 50 cos 25. 45.3, I think, right? Is that right?
Yeah.
Yes? 45.3. That is the horizontal component. But now you have to do what? Yeah. In this case, it's the horizontal component plus friction, or the horizontal sum. 45.3, then minus 5. 40.3. But that is the net force. F net is equal to MA. 40.3, mass is 10. Divide by 10. 4.0. I guess 4.03 to 1 decimal place would actually be 4 meters per second squared C.
And there's no checkbook there. There's no mark.
I didn't even put an answer, I guess, for that one yet. This is one of the new ones that I added in. My apologies. You guys, that's what happens the first time. Okay, so based on what I see, more or less, I think we're not bad shape. There's a few pockets of uncertainty, but as a whole, I think not too bad. Okay, you got a few minutes left. I think I printed the hand-in assignment, but I think I need to go pick it up in the English photocopy. So I'll be back right away.